So, okay, so we are going to start with the ETABS. Now, when you open ETABS, you will get this window in front of you. You have to start with the new model or existing model if you have worked with that one before. Now, we are going to start with the new model, and you have multiple options to start with the new. You will find here in the screen written new model, or you can find this small button here on the toolbar, or you can go through the file and you can open the new model from there. So you can use any of these options to open a new model. Now, when you click on the new model, a new window will appear in front of you always in the ETABS, which gives you some setting related to your code, because later on you are going to design your things through this software. Let's say you are using in your senior design project this software, so you have to tell the software what units you have to use and what code you want to use for that one. So in concrete design we are using ACI code, and for the steel you have British standard or AISC standard. Now, if you look at here, the first window is showing me a user default setting because I already use this setting many times. But for your purpose, you have to go to the use built-in setting. When you click on this one, it will give you the options to choose your units, which units you want to work. Let's say you are working in the foot-pound system. Maybe in the market you go, they are using foot-pound system or metric system. So you can select the units from here. You have to define those units from the beginning. So in our case, we are using System International, which is metric, kilonewton, kg, meter. So I will select the second option. Then you will see here steel section design database. Now in our class, we are dealing with the reinforced concrete, but I'm just showing you this option because this is your first time interaction with this software. So you will click on this option. You will find multiple codes internationally which are used is available there. Like for your steel, you are using British standard. So you can select BS shape, which is British standard. We have American standard 14th version, 15th. In the latest updated one, which is published this year, ETAB, it has the latest code also available. So you have to update your software every year. You will get the update of the codes also in the software. Now, we are not dealing with the steel, but I'm showing you here AISC 14, which is the American Institute of Steel Construction. 14th version is selected. Then the steel design code which you want to use. You can come here. You will find all British standard 5950, which you are using in your steel design. Then Canadian code, Indian code, and American, all codes are there. Now, in our case, we are interested in the concrete design. If you are going to later on design this beam through the software, so you have to choose American Concrete Institute, ACI 31819. So this year we have 25. The latest code is now going to come this year. So later on, you try to install ETAP new version. So you will get ACI 318 25th version available. Now you can see old codes are also available in the market. Some people are not using the latest version. They might be using the old version. So you can select if your company or the workplace is using old code, you can use that one. Now we are dealing here in our course 318 with the 19th version. So I'll be selecting that one. Then I will say OK. Now these are like my default setting for the entire interface. Now whatever the design I'm going to do, it is going to be done through the ACI code. For the concrete and for steel, it will be ASIC. Okay. And the units which I'm using is metric. Now, when you select metric unit, new window will appear in front of you. And you can see here, everything is in terms of meter. So the dimensions which you need to enter is in terms of meter. Now, a default window is in front of us. You can use the benefit of this window also, or we have many options to start with that one. There are options which gives you only the grid lines, blank screen, or you want to model a steel deck directly. So you want to model a truss system, flat slab with beams, because it is related to the building structure. So all type of buildings which are available, common structures, rectangular, it is directly available there. You can select that one. But if you have irregular shape, these options will not work for you, because here it is all square or rectangular shapes you can do. But normally you will not find in the market these regular shapes. Nowadays, with the architectural requirement, shapes are changing floor by floor. So I'll recommend or start with the grid only. Develop your grid structure and then model your things yourself. Okay. Now, if you look at here, I will be selecting grid, and then it is asking me how many grids I need to enter for the beam. Now, because the software is dealing with three-dimensional system. Now our beam is 2D, because I'm going to model, you have an option to model entire building in the ETAB. So you have to go with the three-dimensional system. But in our case, I'm just modeling only this beam. So I'm taking this beam out. So I need to model it as 2D. Now for 2D, software will not understand it is a 2D or it is a 3D. You have to give grid in 3 dimension and then work your things in 2D. So our beam size is, let's say we have 6, 8, 8. Now, best recommendation to work in 2 dimensional is what you go with X, C system in the ETAB. Okay. When you are modeling your 2D, you should model your 2 dimensional system in XZ axis. Okay. And consider the other axis as your third dimension. Now, if I model this beam in XZ direction, so I will be considering up as V and this as X. Now, how many grid lines? The software is asking grid lines. Grid lines are dividing point where you want to model your supports, you want to model your beam. Now, if I look at here, this is my first point. So I can call this grid as 1, 2, 3, and 4. Now, I recommend as a structural modeler that you should divide your grids at every change in the load also. If I have a point load acting at this location, so I will put a grid point there also, so that I can apply directly the point load at that location. Now, in our case, there is no point loads acting on that one. So my grade division is here 1, 2, 3, 4. So I need how many lines? 4 lines on which axis? X-axis. Now in Z-axis, I don't need any line, but the software need 3 dimensional system. So I need to define at least 2 grid lines. There is no other option. So this is 1 and 2. I need to define because this is software is taking it as 3D. So let us look at here. So number of grid lines in X direction. If you see by default, it is there 4. You can change this one if your grid lines are more than that one. Now, what about in Y dimension? I said that it is 3D. So I need to define at least 2. So I can put 2 here. And now in Z axis, now in ETABS, ETAB is not directly telling you Z axis. Okay. It is telling number of stories upward direction. So if you look at here, story dimension. Now, what is story height? If you have 3D building, you have to tell the story heights there. How many stories you want to model? Now, in our case, I'm dealing only with the beam. There is no story. So I can tell number of story minimum 2. I need to tell the software, and or I can go with 1 also, 1 floor system. But let's say with the two, it is just a reference line. It is not modeling anything. Modeling will start later on. What is the story height? You can keep it as it is, or you want to change, you can put the number there. And what is the bottom story height? So when I'm saying two, means I have first floor and the second floor. So I need to give the height there now. This is one approach directly from where you can enter the story and the grid lines. There is another option which is called customize grid spacing. This is another way. You click on this customize grid, you click on edit grid data, you will see that it is asking now the coordinate system. Now, coordinate system, which is like you have to start, if this is the B, I will consider this as my first point, which is 0 meter. Then 6, then no, no, 6 plus 8, 14, and then plus 8, 22. So this is another way you can start with this one, and this will give you direct spacing of your grid system. Now, if I say 0, then 6, you can change it to 6, then 14, then 22. And if you see here, when I'm putting a number, these lines are also moving. If you look at here, you can see here the movement. Now, in Y direction, surely I don't need, but as per the software requirement should be there too. There is, it's already there 0 and 8. You can keep that as it is. No need to remove that one. You can click OK. So your grid lines are now there. Same thing we can do for the story height. You can come, edit. Now, what is our first story? Base is 0. Then first floor height, then third floor. So you can put these heights there. Also, you will get, let's say your ground floor height is higher than the first story. So you can put 4 here, and then you can put 3. So you can see here 4, and total become elevation of the building become 7. But this option is useful when you are dealing with the three-dimensional system. We'll see three-dimensional later on. So I will click OK. And once I say OK here, you will see that two windows are going to come in front of us. One window is going to show us the elevation, and your 2D should be modeled always in the elevation. Okay. And the other is the three-dimensional view. So if you have three-dimensional building, you will get everything in the three-dimensional also. Now, modeling, usually we don't go into this place. We model everything in the elevation. You assign beams, column, then move to the next elevation, you assign beams, column, and automatically it is appearing in the third 3D view. Okay. Now, in our case, we have a beam. I can model it at this location, and or I can model it at this location, because this is just a reference grid line. So because there is no beam, it is like an AutoCAD reference place, and you can just go and model there. Now, to model the beam, if you look at here on the left side of your screen, there are a lot of tools given to us. Now, each tool is helping us to model each simple element. Now, if I put a cursor around them, it will by default give you an option. What is this? Oh, it's not appearing here. The view is, maybe I'll make it a little smaller. Then it might appear for you guys there. Okay. Now, if you look at here on the left side of the screen, there are these tools available. Now, if I bring cursor to each option, it will tell me. If I bring, you can see here now, it is telling me draw beam or column or bracing. Now, beam and columns are always modeled by line element, the way which we are dealing in our structural system, the representation of our beam. Then if you bring your cursor to the second option, it is to model your beam and column in a quick way. And I will help you understanding both these two options, how we are modeling using them. Then you bring to the third, it is telling you draw a column, but this option in a plan view. If you see in the bracket, it is stating that you can model your column in a plan. So if I have a plan from the top view, I know there is a column. I have to come to that joint and use this option, and it will model the column vertically in that option. So this is how each option work. You have to explore these options one by one, but I'm just giving you a quick. Then if you come here, this is to draw the floors and the walls, if you have walls or floor system. Now, I'll be using a line element and I will use one by one each option. But before that, now software needs some inputs. What are those input? To model any element, beam or column, you need to tell the software material properties. Without material properties, it will not consider that what is that beam or what you are considering there, because later on you have to design that one. So it needs concrete strength, it needs steel property. So how we can do with that one? I will go to the define option. You click to the define option. First option is about the material. You need to click on the material property. And when you click, there are by default some material properties are already given here. Okay. Now, each material property is related to steel and the concrete. Now, we have structural steel, which is used in the reinforced concrete members. We have structural steel, which is only used for the steel design, because both have different properties. Now, these names are given by the software, which represents American standard. Now, if you look at here, there is FY is written. FY 50 means 50 KSI steel. Now we are not using metric system, foot pound system. We are using metric. So how can I know what is the strength for this? You can just click on modify and show material properties. You will see the name of the material is given, which is A992 FY 50 KSI. What is the density of the steel? Normally, we know that density of the steel is, what is the density of steel? Steel. I'm talking about the density of the steel, not the concrete. 7810 in kg. Okay, so when you convert into kilonewton, so this is, so you can see here by default, it is giving us the density of the steel also. You don't need to put that one. But if you are defining new material from your side, you have to input these numbers there. Next, modulus of elasticity of steel. What is the modulus of elasticity of steel? 200, approximately. You can see here 199 given. So which is 200, or you can change it to 200,000. Okay. Megapascal. Okay. Then Poisson ratio of the steel. All this depends which type of material you are using. Now, what is the FY? FY detail is not given here. So what I need to know, I need to click on what? Design properties. When you click on design property, you will see what is written here. Grade 50, which is 50 KSI, which is equal to 344.74 megapascal. FY here it is 334. This is not for the reinforced beam. This is for the structural steel. If you go to you are taking steel design with Dr. Abdul Hamid, what is the yield strength he's using? 300, 350, 275 megapascal. So if you look at here, this is around 345 megapascal. So this is related to the structural steel, which is used for the steel design. Then you have the ultimate tensile strength. So these properties are already there. Now, I just explore one for you. Otherwise, you can define your own material by clicking on add new material. It will, by default, it will show you what things you need. You are dealing with the US region, you are dealing with the China or any other region. You can come mostly because if you are dealing with the US standard, we will stack US region. Then which steel you are dealing? Are you dealing with the steel or you need to deal with the concrete? You can select that one. Then which standard you want to use? We have different standards available. You can select that one. And then which grade steel you want to use. So first the structural steel, only grade 50 is available. 345 yield strength in the design we are using that one. Now, This is one option. Other option, if you look at here, 4000 psi. 4000 psi means 28 megapascal. This is the strength of the concrete. When we see psi units, it means always strength for related to the concrete. If I click modify on this property, you will see by default it is saying it is a concrete material. Then what is the density of concrete we are taking? 23.6 last time I showed. And if you look at here, what it is showing, 23.56, which is 23.6. Then modulus of elasticity of the concrete. Now we showed you one relationship which was 4700 square root of FC prime. Just put 28 megapascal in this one. Give me the number if you can check this quickly. So around 24855.58. So this is like approximate already software has done. And if you look at the strength which it is taking around 27.58. So I said that 4000 psi is approximately equal to 28 megapascal. So strength is there. Now, these properties are currently not required because what we are looking in our problem, we just want to get bending moment diagram and shear force diagram. Our main target is not design of this beam through the software. But if you are designing your things, you need to enter these properties correctly. Otherwise, the design which you are going to get from the software, it will not be correct. Okay. So I will not touch these properties. I will keep them as it is. So currently material properties, we will use default material properties because I'm not designing anything from here. After the material properties, we need to define a section. Now, when you click on the section properties, first option is frame section. Beams and columns are always modeled through the frame section. When I'm saying slab or walls, they are modeled through the slab section or through the wall section. Now we need to use frame section to model beam. I will click on frame section. By default, there are from the code, lot of frame sections are available, which is related to steel, structural steel. If you go to the steel manual, which Dr. Abdul Hamid gave it to you, you have W section, you have I section, you have H section. All of them are here available. All their properties, everything is available inside the software. But because we are dealing with the concrete, so what I will do, I will go and add a new property. I will click on this one. A new window is appearing. What type of concrete section you want to model? You want to model rectangular, circular, T or I section. You select your shape. Our shape is rectangular, 500 by 350. I will click on this one, 500 by 300. I need to call it as beam. Then rectangular section by default there. What is the strength I'm using? That's why we need the material properties to be correctly entered. Otherwise, when you will design that beam, software will take 27.58 megapascal. Now, as I said that we are looking only for the bending moment diagram and shear force diagram. This will not affect our results. Next thing, what is the depth of the section? 500. And what is our width? 350 we choose. Now, if you look at here, reinforcement is given already. Okay, now this, if you look at here, I need to go and click on the modify reinforcement. Do I need to check for the column or I need to check for the beam? I will click on the beam. Now, what it is asking, where you want to put your reinforcement means cover. You need to define the cover so that software will select effective depth properly. Okay. Now, all these things again required for the design part. I will not touch them because we are not looking in the design currently, but I will just change it to the beam and I will click OK. You will see now reinforcement has been gone from this one and your section is there. you can click OK. But if you want to know the properties of your section, you can click on Show Section Properties. It will give you area, moment of inertia, all calculations which you are doing manually is done now already for this section. Now I will click OK. Now our beam is defined as beam here. Okay, I give the name it as beam, so it is there. I will click OK. Now our section is there, which we have to put here as a modeling. Now I will make this screen smaller so that I can use those options. Now if you look at here, first option, draw beam. I said that we have two options here to draw the beam. One is this one, another one is this one. I will use both one by one to give you difference between. When you click on the first option, if you bring your cursor here after clicking this one, a new window will appear, which will ask what is your section. First is frame. Second, what is the property? Our property is not a latitude. I need to click here and select our beam, our section, which we define. So I will click here. So now it is beam. Now I will bring my cursor here. Now it will start asking me to touch the node. If I bring cursor here, it will not show me anything. But when I bring the cursor to the joint, the intersecting line of the grid, a plus mark is going to appear there, red color. You click now, and now you can see if I move my cursor after clicking, it is showing me dimension and the length of the beam, which I have to model. Now, let's say I will bring cursor to the second grid line and I will click here. Now, one beam is model, that part of the beam is model. Now it is continue until I finish all my modeling. This is one option. It works only node to node. Now I will select escape to cancel this option. When I cancel, now you can see one beam is there. I did not complete it fully. I will use now second option, which is called quick beam draw. Now, when you click on this one, again, that window is here asking type of beam section. You need to click on beam. Now, this option is very useful to model your beam very quickly. It does not require node to node. It needs only the line where you want to model. Now, if you look at here, when I'm bringing my cursor, it is showing me grid to grid model of the beam. I can click now quickly and it will model. I don't need to select node by node, but sometimes node and by node option is required if you have irregular grid system. So this will not pick the grid. So you have to go from one node to another node, then you will model. So that's why these two options are available with us. Now our beam is there. I will press escape. Three beam lines are there. Now, by default, software will consider their connection as continuous. If you remember, when I click on this option, what it is saying, moment release continuous. So wherever you, even if you model your line one by one, it will consider the connection at grid line as continuous. Okay. So it means it is a continuous beam until unless you release it yourself. You say this is not a continuous beam. Now, next thing, once the beam is there, what is our next thing? Support. First, support, because I need to first model everything structurally. Then I will start applying the load on that one. Now, how we can apply the support? You have to go to assign. When you click on assign, first thing is joint. Under the joint, you will find restraint. Restraint means support. And if you see here, there is a bell shape there. When you click on this one, your all traditional supports which you are using is there now. If you look at here, you have fixed support, you have pin support, you have roller support, or you don't want to put any support, only a node there. Okay. Now, if I click on fix, all 6 degree is selected because software is considering it as a 3D fix. If I'm clicking on pin, three-dimensional pin, it is not going to move in X, Y, and Z. If I click on ruler, only one direction, one reaction, because ruler give only one reaction. So it will be restricted in Z, and Z is upward. So your ruler will come in this direction. So in our case, we have pin. I will select pin, and now I will go in the background and I will select the joints where I want to put the pin. If you click, okay, now if you click here, cross will appear, then cross, all the location I will pick, and then I will say apply. Okay, it's there, but which view I'm looking? X and no, X and Y. What view I have to look? X and Z. So supports are there. I need to change the elevation. I will click on elevation. Now, which elevation I need to see from your 3D? It will tell you grid which one. If you look at the 3D, this is X, Z plane. I need to look at this elevation. So what grid line I need to select? One. Okay. Now I model. Now XZ plane is there. What is the next? Where are our beams? Where I model our beams? On the grid line number 2, the blue lines are where? On the grid line number 2. So what should I do? Go to the next elevation, which is by either you click here or these arrows will allow you to move to the next elevation where you did your modeling. Now our modeling is done there on grid line. So you can see here now your beams are there. Now these story numbers, story 1, story, they are not affecting your result because these are just a grid line. I'm not modeling 3D, I'm modeling 2D. So software will consider your beam only on that location with the pins. Now what is our next thing we need to do? Apply the load. Now to apply the load, I need to select the beam. Okay, now loading is very important here. Before that one, we need to understand some of the important thing in the software for the loading. Now, first I need to define what type of loads are there. I have dead load, I have wind load, I have earthquake load. So I need to first define the type of loads I have. Okay. Now, if you go here, define, under define, you will find an option called load pattern. You need to click on load pattern. You will see different names given there. By default, always dead and live load will be available there. Now, this dead is not that dead load which you are going to apply. This dead is representing the self weight of the member. Now, in our calculation, do we need self weight to be added on the applied load? Because what I did yesterday, I added self of weight of the beam and I come up with the number, which is, if you look at this number, what is this number showing me? It includes already self weight of the beam, floor load, everything 18.6, which already include the self weight of the member. Now, if you go here, there is written called 1. What is 1 representing? Here 1 and 0 represent on and off. It is not some magnitude. It is like language of computer or electrical circuit, on and off. If I keep 1, means I'm allowing the software to compute the self weight of the member itself. From where it is going to compute? From the size of the beam which you define and the density of the concrete. So let us use this option to understand, because in future you are going to use, because when you have big buildings, it's difficult to compute the self weight of each member one by one. So I'll keep this as 1. Now, what is the next thing? Live load. What is the other thing? Superimposed load. Live load 0, because software will not compute. I will put the number for the live load. Next thing, we have superimpose load. You will define superimpose load, any name you can give, super I, and you add with the magnitude 0, because when I'm saying 0 means I will put the number. 1 means software has to get, but software doesn't know what is the superimposed load you want to put. So I'll always keep it as 0. When you add this number, now you have dead, live, and superimpose. You just save it. This is just a combination you created, unfactored combination. Next thing, I will go to define again. I will create a load case. Under the load case, you will see dead, live, superimpose is there, unfactored. But I need to create a factored load. What I do, I will go and say add new case. When you click on this one, it will start asking the name. I will say 1.2 dead load. Okay. I will create only for 1.2 dead and 1.6 live separately. Now 1 point dead, this is the name I give. Click on add. What are the dead you want to add? I want to add self weight, which is what is the factor you want to keep? 1.2, because it is a factored load. Next, add. What is the load you want to add? Superimpose load. Click on superimpose. What is the factor for superimpose? 1.2 again, because dead load. I will say okay. Now you can see your combination of 1.2 dead load is there. Now I will create 1.6 live load, because we have to play with all these things. I will come and click add, and I need to change here to live. And what is the factor for live load? 1.6. I will say now combinations are there. If you want to add them together, you can also create a new combination by adding them. Now, if you look at here, your load patterns are there. You can create a new combination, or you want to combine those loads, you can also do that one. Okay. But I will just treat them separately because we need to model each load combination separately in our problem. I will click now. Okay. Now combinations are defined. Dead loads are there. Yes.
So can you go back to the defined load?
Okay.
Yeah.
Load pattern or a load combination.
Okay.
Okay.
So we define some bottom post as live load.
Superimpose. Yeah, we need to change it to dead. Yeah, sorry. This was dead. Okay. So you can modify this one. It is now superimpose dead. Okay. Now, okay. Now you have your loads. If you want to define combinations, go to define load combination, add combo, which loads you want to add. 1.2 dead. But I will not change scale here because I already factored them. If you change it here, it means you are doubling that one. Okay. So keep it 1, add next 1.6 live, and you can call this combination as 1.2 dead load plus 1.6 live load. If you want to see the bending moment diagram for this entire as one. So you will say, okay, here. Now you have one combination also available. Our next task is to apply the load now on the beam. How we can apply? You need to select the beam, all the beam. Okay, dead load self weight is defined. I will not apply self weight. I need to apply only the live load and the superimposed load. I will go to first I will select, then I will go to assign. Under the assign, you will find an option called frame load, because beams and columns are frame. Under the frame load, you have an option of applying point load, distributed load, or temperature load. Our load is distributed. So I will click on distributed. Now, what is the load you want to apply? Do I need to apply dead? No, this is self weight. I need to change the pattern, which is superimpose. First, I will change. Then, is it trapezoidal load or uniformly distributed? Uniformly. I need to put now number here. Now, what is our load number? Just add this 13.93 and 11.6 because self weight, I asked software to compute itself. So what is this number total? 13.93 plus 11.6. 25 point. Oh, sorry, don't add this one because we are adding live. This is dead and live. So we need to treat them separately. So it is 13.93 is our superimposed load. So I will directly go here, put 13.93. And when you say apply, you will see now your uniformly distributed load is there. Now I will click OK. I will apply now live load. Now live load, we need to apply in multiple location. I have to create multiple cases. Now to create those cases, you need to create combination. Case 1, case 2, case 3. Now, again, you can go here, create a combination. What is that combination? You can call it as case 1 or case 2. That is your choice, okay? So for the timing, we will come to the live load later on because the time is already finished. I will just run the analysis to show you the dead load answer, okay? Now, once you apply this load, and you have to apply live load also the same way, okay? I will go to the run analysis. You will find a play button there, or you can go to the analyze and you can run from here, okay? So when you click on run, it will ask you to save your beam. I will say it is a beam test, whatever the name you want to give, and save. Now, when you click on this one, it will run for a few seconds. It will take and it will show the deform shape after completion of the analysis. Now you can see here deform shape has been created. Next thing I need to see what moment diagram and shear force diagram. If you come here, this is the frame shown, frame with the moments. It is the option where you need to click to get the moment diagrams and shear force diagram for your beam. Now, if you click on this one, it will ask you want to see for what? Only for the dead load. You want to see for the superimposed load, or you want to see for 1.2 times dead load. I will see for the 1.2 times dead load, and you want to fill the diagram and also you want to see the numbers or not. So if you see here, show values. So if I click on values and say apply, now it is showing us these numbers here. Okay, you can see here the numbers 107 and all in terms of what are the unit we choose? Kilonewton meter. So moment will appear as kilonewton meter. You can right click on the beam to see each beam separately, how the moment value is changing location to location. And these are the results which we are going to use later on in our ETAB and other diagrams. We will see those things later on. This is how you will perform, and we will continue on this topic with the passage of time. Okay. What's it? Same or is had pro? Yeah, but it is more user friendly because you can change anytime. Instead, Pro, if you have any error, you have to do it from here. You can do. This is what I couldn't get a chance to explain. Later on, I will show you do mistake how to correct this quickly. But we can for when starting into draw, scan to make same stack draw node by node and keep the number manually. Yeah, you only with line. It in this one only with the lines directly you can draw, but you have to define the nodes. In ETABS, you're telling node that you are saying you connect from this node to the. You have to write lot of things. Here you are just drawing it.